video, I'm going to show you how to come up with a ladder diagram. Ladder diagrams used for motor controls, such as having stop push buttons, start push buttons, relays to maintain, contactors, the contacts, the coils, basically every component you need to be able to control a motor. So I'm going to start with a very basic one. And the scenario I'm going to give you is this scenario right here. We use a stop push button, a start push button to run a conveyor. I'm also going to include a jog push button just to see what a jog push button does and how it's wired. And also at the same time, because we have a jog push button, we're going to use a relay to maintain, but we still need something called a contactor to actually allow current to flow to your motor. So the contactor is always needed when you have a motor. A relay is not always needed, but it could be used to maintain, kind of to isolate the contacts so that you can easily add a jog push button as well. So I set up a few things to show you. You've got the relay here. So a relay is basically an electromechanical component, but it's not used directly to control the motor, meaning that current won't flow through your relay to get to your motor. You're going to use a contactor for that. These are the symbols that you find in ladder diagrams that are associated with the relay itself. So you have the coil. So this is an electromagnet. When you activate 2 and 7, this becomes magnetized, and all these contacts here are contacts found in an 8-pin relay that has 2 sets of contacts. Now, when we say 2 sets of contacts, you have a normally open contact and you have a normally closed contact. Notice you have a 1 here and you have a 1 here as well, and a 3 and a 4. Well, these numbers all mean something. 1 and 3 on a plan means that it's normally open, as you can see by the contact here. 1 and 4 is normally closed. These 2 1s are actually on the same screw on a base for a relay. Same here with the 8. This relay contact here, this relay contact here, this is normally open, that's normally closed. It's part of the same relay. But when the coil is energized, this 8 and 6 will close, and this one here will open. But like I said before, this 8 is actually the same 8. You may need just to normally open, you may need to normally close, but you can use both. So we'll see one example of that. So another component we'll be using in this ladder scenario is the contactor. So the contactor and the OL as well. So the contactor, this is a symbol for the coil. Before we had a coil, it's basically a circle. The numbers here indicate that it's, in this case here, an 8-pin relay. Here for the coil, for the contactor, it's always labeled A1 and A2. So it's got a slightly different numbering system. Here we're using a North American numbering system. There also is an international numbering system that could be used as well. But since this is what we're using mostly, this is what we'll stick with. These numbers here are for contactors, and they use a slightly different method. As we'll see when we start putting in stop push buttons and start push buttons, there's a reason why this is 3 and 4 or ends with 3 and 4, and this normally closed contact ends with 1 and 2. Anything that ends with 1 and 2 is a normally closed contact for contactors for push buttons. Anything that ends in 3 and 4 is a normally open contact, whether it be for contactors or for push buttons as well, like a start push button, a forward push button, or a jog. And this is your coil. So one more component that we'll need for our ladder, because we have a motor, we have a motor starter. A motor starter consists of a contactor and a coil, and an OL, sorry. So the contactor and the OL work hand in hand. And the OL will basically trip or open up. This contact here will open up, de-energizing the coil, which will then de-energize the motor. So we'll see how that works in the ladder diagram as well. Okay. Got a library here, a page where I'm basically showing you the sets. So I have a relay with 2 sets of contacts, basically an 8-pin. These are all the contacts I showed you and the coil I showed you on the previous page. This section here shows you the numbers for an 11-pin. Right? So it's good to have as a library of all the contacts you may possibly need for an 8-pin or an 11-pin relay. Here we have a contactor, and we have these 3 contacts which I didn't draw at the top because this is part of the power circuit. So if you see L1, L2, L3, T1, T2, T3, These are the main contacts that provide power to your motor, whether it's a DC motor, single-phase motor, or three-phase motor. This, again, is the coil. You sometimes see the coil for a contactor with two circles, a double circle. That indicates that it's for a contactor. These are auxiliary contacts, okay, that you can purchase separately, that are attachments that can be top mounted or side mounted. I'm just going to add one contact that's missing here that I drew at the very top, and that's the fourth pole. So you have 1, 2, 3. This would be the fourth pole that you would find on a contactor. You have 13 and 14, again numbered 13, 14, which ends with 3 and 4 because it's normally open. That's your contactor. So we're not going to get into timers in this video here, but here are the OLs I was referring to before as well. The OL contacts, well, if the OL trips, this symbol here is for the power circuit. So in other words, these 3 OLs would actually be installed here. So you'd have every phase going through a set of OLs and then going to your actual motor itself. So when your motor, when there's too much current going to your motor and your motor is in danger of overheating, what's going to happen is this OL detects the amount of current. There's different technologies. There's some with little heaters, some with CTs or current transformers. But what happens is, depending on what you set the OL to, the dial on the OL, these contacts will change state. The normally closed 95, 96 contact will open, and the normally open contact, which is number 97, 98, will close. So this 95, 96 will open a contact to de-energize the contactor coil, which will de-energize the motor, and the 97, 98 will close, and that can indicate a light, like a warning light, that something is wrong with the motor. So it all depends on how you wire it in the control circuit. All right, so I'm going to start the ladder diagram. So I'm going to start with a stop push button. So this is a symbol for a stop push button with the horizontal line going at the bottom. When you press down on the stop button, this line here will go down, which means that it's no longer making contact. So this is a normally closed push button. A normally closed push button, just like the 21, 22 contact that I showed you on the contactor contact before, it ends with 1 and 2. So this would be the line. You can also show this as one vertical line here for the line and another vertical line here for the neutral, but I'll do it a different way for this video here. We have a start push button. So a start push button is a normally open push button. So if we label everything, this is a stop push button, normally closed. This is a start push button, which is normally open. So we have to start getting used to the numbering. 1 and 2 for normally closed, 3 and 4 for normally open. Since we have a jog push button, I'm not going to maintain with the contactor. I'm going to maintain with a relay. So this is the relay that we saw right here, the relay coil. And we use the 1, 3, the first one. You can use the second one as well, but we'll go in numerical order. So the 1 and 3, which is the first normally open contact. And we put this contact in parallel with the start push button that activated the relay itself. And it's called a maintain. So you press start, you activate the relay. This contact will close, which means that current will flow through the stop, through this contact, which is going to be closed, and activate or keep the relay maintained, and you can let go of the start push button. So you're basically just pulsing the start push button. We're going to add the OL, which protects our motor from overheating. So we'll label that OL. So the relay coil was 2 and 7 for an 8-pin relay, which is what we're using, and the OL is 95, 96. Now, one little trick to try to remember these numbers is to look at the stop, numbered 1, 2, and just increment the count. 1, 2, a start, 3, 4, and then we have a 5 and 6, just to help you remember what these numbers are. And also what this will help you do is remember that 1 and 2, which is the stop, is normally close. So when you start using contacts off of the contactor, these will be the last 2 digits of the contactor number. So the relay, different set of numbers here in North America. We're going to use 1 and 3. Some relays do come with both sets of numbers, the international and the North American. So that would be 11, and this would be 14, which is normally open. So right now I have a stop start. I press the start push button to activate the relay. This contact closes, it maintains. But I want to activate a motor. If I want to activate a motor, I need a contactor coil. This contactor coil, we go back to the library here. That contactor coil will close these 3 contacts, supplying power to your motor. So that's the goal here, to activate the contactor, because I can't use a relay because the relay is not made to handle that much voltage and that much current. So I have a contactor. What I'm going to do to activate this contactor is I'll use the second set of contacts off of the same relay, which I labeled R. The second set, it's right here, 8 and 6. 8 and 6. The labeling for the coil, not the same as the relay for a contactor. It's A1 and A2. And I'll put it right before the OL, so if the OL trips, I deactivate everything before it. So I press start to activate the relay contact closes. This contact closes as well. It's the same relay. Current will flow and activate my contactor. If ever there's an issue and there's too much current going through my power circuit, the OL will trip, 95, 96 will open. If I wanted a pilot light to come on when the contactor is on, I can put a light directly in parallel with the contactor, but to confirm that the contactor is actually engaged, the better way to do it is to actually use a contact off of the contactor. And since I use the maintain of the relay here, not the maintain of the contactor, what I can put here is a contactor labeled 1314, which is the 4th pole of a contactor. So I'm going to go back and show you the library here. We had 1, 2, 3 poles. That's for the power circuit. We have this 4th contact off of the contactors that we use. That's labeled 1314. And that would turn on a light labeled X1, X2. Okay, that's a symbol for a light. If it's a yellow light, you can put a yellow in there. Okay. So one thing I didn't put yet is the jog. So what I want to do is, I don't have much space here, so I'm just gonna, this is the way you would put a light, or the ideal way to add a pilot light when the motor is on. I'm just gonna erase it, and I'm gonna add the jog. So the jog basically goes directly in parallel with the relay. In other words, if I press the start, I activate the relay activates the contactor, but if I press jog, remember jog is inching, there's no maintain here. Since it's a normally open contact, it's still 3, 4. So if I press the jog, I activate the contactor directly. If I activate the contactor directly, I'm not activating the maintain, so it won't maintain. And I'll put the light back as well. So I'll put the contactor contact, 13, 14, activating a light. The symbol for a light is basically almost like a coil that's got these 4 lines going out at angles, and labeled not A1, A2, but X1, X2. And if you want to indicate a specific color light, we put that right in the center. It's a, actually, let's go with red. Go with red. I'll add one more thing. If ever the OL trips and the motor is overheating, so the OL would trip and the motor would stop, therefore protecting the motor. If I'd want to indicate that on a panel door, what I could do is I can take the power directly from here or from the line, and then I'll use the second contact off of the OL, which is normally open and numbered 9798. And I would turn on, let's say, a yellow or amber light in that case there. All right, if you wanted to, you can actually turn on a flashing light or turn on a timer, put it on flash mode, and that would allow the yellow light to flash and maybe bring a bit more attention to it. So doing it like this actually wouldn't work for the yellow light, because if something were to happen, the 9798 here would open, but the sorry, 9596 would open, but the 9798 here would close, but current going through this contact here would have no place to go back to the return, which is the neutral. So this last wire here, which was going to 95 of the OL, actually has to go directly to 96 or the neutral for it to work correctly. Just zoom out here. I'm going to reread, see if we did everything. Use a stop push button and a start push button to run a conveyor. Use a jog push button as well so that the conveyor can be inched forward. So this is only a one direction motor. If we were to use a reverse as well, basically we'd be replicating this section here. We'd have a second contactor, and the power circuit would be a little bit different because you'd have a forward contactor and a reverse contactor. And depending on the type of motor you want to reverse, there's different methods to do it. So basically, this is a ladder diagram for the given scenario with all its numbers. I'm going to show one more thing, and that would be how to actually number wires and how to number lines. So we'll start with line number 1 here. Every component, so even if it doesn't go all the way from left to right, is still considered a line. That's line 2. This is line 3. The jog is on line 4. This is line 5 and line 6. There's another thing we can do, and that's cross-reference where we'd find the contacts for every coil. So since we have a relay coil here on line 1, in parentheses here, what we can put is, so in this case here, I mean, it's a very short ladder, but if you have a multi-page ladder, this would help you troubleshoot because you know exactly where to go verify to see if there's power, what line, where that relay is located. So again, for this line here, for the relay, where are its contacts? Well, I have a normally open contact here on 2, line 2. Do I have another relay contact? I do right here, and that would be on line 3, so I put A3. If ever you'd have a normally closed contact, well, then you'd put a not on top of the actual number. So here I've got a contactor. Do I have a contactor contact? I do on line 5 right here. So this is a 5. This is a red light. This is a yellow light. Well, if a red light comes on, it doesn't actually activate a contact, right? It's not part of a coil or an electromechanical device. So there's nothing to be put on these control loads here. The very last thing I'm going to show you in this video is how to number wires. So numbering wires is a method to wire things as accurately and as precise as possible, and also to troubleshoot. It really facilitates troubleshooting because every number in a control panel that's, let's say, number 3. Well, if one number 3 has power, well, then all the number 3s have power, okay? If the number 4 has power, well, all the number 4s have power. If you start having certain 3s that have power and others don't, well, then it kind of narrows down the search. You know where all the 3s are. Some can be on the relay, some can be on the push button, some can be on the contactor. So the way we start that, we can start at really any number we'd like. But I'm going to start with a low number here, a number 1. I'm just going to circle it so we start having a lot of information here. So basically, I'm just going to encircle a number 2. Now, the reason I went from 1 to 2 is that every time you have a component that can change the flow of current, I increment the count. So in other words, if I have power between line and neutral, so I have a multimeter and I go between line and neutral, I have power. Well, if I put it on pin 2 of the stop or pin 3 of the start, and I press the stop button, well, I won't have power going to it. So it interrupts current flow. So if it does interrupt current flow, I increase the count. So we're going to go from left to right, from top all the way to the bottom. So I've got a start push button. I'm going to increment that to a 3. So this wire here, let's say one is on the door of the actual control panel, one is on the inside. Well, both ends of these wires would be wired or tagged number 3. Same thing for the relay pin 3. What I don't like to do is continue with number 4 here. A neutral is a neutral. I want to keep it kind of separate. So I'd start off with a 0. But since I do have a component here, just because I have a neutral here doesn't mean the neutral is getting through the OL, because the OL can trip or become defective, or a wire may be loose. But what I like to do is I'll just label it 00 or 01. Generally 00 is what I do. That's 00. This is also a 00. And this yellow light, well, it's X2, which I didn't write down. So this is X1, X2, is actually going to the main neutral, and the main neutral is labeled 0. So I stopped at number 3. I'm going to go down. And since there's no component here, these are all daisy chain. So all of these are number 2. That's a number 2. This is a number 2. This is a number 2. And we've got 2 more, one there and one there. All these would be labeled number 2 in your control panel. As I said before, if you put your line or one of your leads on any of the 2s and the neutral, you should have power. If you go to 3, well, you only get power if you press the push button, and so on and so forth. So since I ended with number 3 here, I'm going to continue numbering. I continue with number 4 here. So I increment by 1. This is a 4. This is basically 2 ends of the same conductor. Nothing in between these wires. They're just daisy chained together. So I ended with 4. The next available number is 5. This is also a 5. And the next number is a 6 and a 6.